Hello there and welcome again to this exciting tutorial. In this video we will explore how to utilize a custom YOLO model to detect vehicles on a highway, and we will extend the same use case to count the number of vehicles moving in and out in all the lanes of the highway. We will be taking input this video and we will be generating an output like this. Exciting, isn't it? So let's start our journey of object tracking and counting using custom YOLO model. Okay, so here we are with our coding playground. We have imported all the necessary libraries which we are going to need. I'll be using YOLO for object detection. I'll be using OpenCV for image manipulations, and we'll be using DeepSORT for object tracking, and we'll be using NumPy for conversion of our tensor object into our list object. Now let's start writing our code. So let's name our function. Let's name our function process image. Let's specify the path of our video. So path is equal to, where is our video? There you go. Let me copy the path from here, copy path reference, and there it is. Let me just paste the path here. Now just for the sake of convenience and clarity, let me play the video once again for you so that we are clear on which video we are trying to run our algorithm. Okay, so here is our sample video. Our goal here is to detect the moving vehicles on all the three lanes, and then we should count how many vehicles have moved in each lane. Let me cross the video. Now before we apply any sort of algorithm on top of our video, let's try to extract each and every frame from this video and let's try to display what that frame contains. So this is how I'm going to do it. Let me first create the object for our video capture method. So vs is equal to cv.video capture. Let's try to print all the details inside a particular frame. So here we'll be printing total number of frames. So what is the format of our video? Now let's try to create a while loop which will extract each and every frame from that video one by one. So while true, we'll be creating two variables here. One is grabbed, which will take care of whether we are grabbing the frame or not. And let's create one more variable, frame, which will contain the extracted frame. So here is one error here. There you go. So this is vs.read. To know if we have reached the end of our video, we will apply this logic and we will break it from here itself. Oh, this is a spelling mistake here. Grab. Okay, perfect. So basically what I'm trying to do here, this is the infinite loop. It will run until and unless we have covered all the frames inside that video, and each extracted frame from this video will be inside this frame. And to display the frame, we will be using OpenCV image show methods. There is our OpenCV image show method. Here we are trying to display the frame. Let me add vechile here also. So here is our vechile. Now let me just run and see whether I'm able to successfully extract frame from the video or not. So let's play this. Okay, perfect. So here is our video. We are able to extract each and every frame from that video, and we are playing with a speed of 24 fps. What we'll do, let's make weight key 500 and let's play our video again. Perfect. Our video has an added delay of 500 ms. Amazing. Now I have added this delay on purpose because once we apply an ML model on top of our video, it is easy to visualize how accurately we are counting the number of vehicles. Okay, so by displaying all the frames in a particular video, we have successfully completed our first step. Now in next step, we will try to apply an ML model on top of this frame. So idea here is that for each frame, we will be applying YOLO model on top of this frame, and we will be displaying the result at the same time using image.show method. So for that, first let me load the model. So let me load the model here, not here. So let's, to make our code more beautiful, let's try to load our model objects from here. So model loading code will be here. Okay, so let me start loading the model. So for this, let's try to first utilize a pre-trained YOLO model. Then I will also use my own custom trained model on this video. But first let's try to use what this pre-trained YOLO model will give us. So we have loaded the model. Now let me try to do predict on top of each and every frame. So let's create one variable result. So the result will contain all the results of a particular frame. And now let's try to do predict on top of this frame. So let me try to decipher the content inside results. So let me create a loop for deciphering the content for result inside results. Hey, data contains all details about our detected object. So each frame we are getting the results here and we are trying to decipher the content inside results here. And each result is containing the data, and data contains all our bounding box details, the confidence of our detected object and the class of our detected object. Let's try to print this data and know what it actually contains rather than just explaining to you. So let me just run it and show you what is inside our data here. Till the time our code runs, let me iterate you once again. Here I am just trying to get all the boxes data here, and I'm trying to convert it into a two list form because by default it's in a tensor form. That's it. Okay, so our code is running and you see here we have printed our data. So this is our bounding box details from here till here, and this is the confidence for our detected object, and this is the ID of our detected object. Perfect. Now let's try to draw bounding box around our detected object. Now to make our life simple, let's create a separate function which will take in input this data and this frame, and it will try to draw bounding box on top of that frame over a detected objects using this data. Let's try to write that code here. So here is our function. So drawbox is the function which will take in input the data, and it will take in input the image here is nothing but the frame which will be passing. It will extract all the xy coordinate details and confidence and id from that data, and using cv.rectangle function from opencv we are trying to draw a bounding box on top of that detected object, and we are returning the image here. Now let's try to call this function. Where are we? There it is. So let's try to call the function from here, drawbox, and let me try to catch that in that frame. That's it. Instead of frame we'll be passing this, and that's it. Now let me try to run and show you whether we are able to draw bounding boxes perfectly or not. Okay, so here is our output. We are able to detect some sort of bounding box on top of our detected object, but you see we are not able to successfully detect the vehicles moving on top of that road. So this is your pre-trained YOLO model. Now let me do one thing. Now let me try to change this model to my custom trained model. First let me comment this, and we'll be using same logic to load our custom model. So my custom model is this. So I have trained this model specifically for a drone based footage on top of our vehicles. So let me just run the whole code again and see whether we are able to successfully draw the output properly or not. Okay, amazing. You see each moving vehicle has now a proper bounding box around it. This car, this black car, even this truck. Amazing. This model works really fine. So basically for this model what I have done, I have taken the footage of all the vehicles from a drone view and tried to train the model. Okay, so using our custom object detection model, we are able to successfully detect each and every moving vehicle on that highway, and also using that draw box function we are able to successfully draw bounding box around our detected objects or vehicles as well. So in next step, we will try to track each and every moving vehicle on that particular frame. Before we start our tracking code, let's understand the difference between is object detection and what is object tracking. Alright, so here is an example of object detection and object tracking in real time. So this is our original image. Let me zoom it for you. So in original image, we have not detected any sort of object. And if we move to our object detection, we see every object in this have a bounding box around it. Let me zoom it more for you. So every object you see here, for example, this bike rider, this vehicle, every object in this have a bounding box around them. Basically it means that every object in this particular frame has been detected by our model, but once we move to our object tracking code, you see every vehicle has been assigned a unique ID. Let me zoom it more for you. For example, this vehicle has ID 3 and this vehicle has ID 24. It means that this entity and this entity are completely different, and we will be tracking this ID across the video. So this is an example of object tracking. This is your object detection, and this is your original image for reference. Alright, now to start our object tracking, we are going to create a DeepSORT object. That's what I'm trying to do here. I have created an object tracker here, and inside that I'm assigning the DeepSORT object. Let's try to use this object tracker in our code here. So inside object tracker, we are using the update tracks method here, and I'm passing two parameters here. The one is details and one is frame. Frame here is quite obvious. It is the same image which we are dealing with, but let's try to understand what is inside details. Now to do the tracking on top of a particular object, we need the details from our result in a particular format. Let's try to see what we are doing inside getDetails method. Input to this function is the result which we are passing, and the image here is nothing but the frame. So let me just revise you again. So we are using getDetails function here, and this result is nothing but it's all the results on a particular frame. So this result here contain all the detected objects, bounding box data, confidence interval, and everything. Now let's try to go to our function. Okay, here we are deciphering all the detected classes on that particular frame, and then we are deciphering what is the confidence interval for all the detected class. And in this line, this is really important here, x and y here will contain the center point, and w and h will contain the width and height of the bounding box. Now let's try to understand this through an example. Contains all the prediction on particular frame, and here from result we are going to extract xy coordinates of the bounding box and height and width in the form of x, y, h and w. Then we are going to need the confidence of the detected object, and then we are going to need the id of particular detected class. All of this data will be combined in the form of a tuple, and then this tuple will be assigned in a list, so that this list contains the multiple tuple, and each tuple will have all the details of x, y, h, w, confidence and id of each and every detection from our frame. So, and here we are appending all the detection in a list, and here is our detection list, and that's what we are returning here. And we will be using this list to do our tracking. Now let's go back to our code there. Okay, here we are, and that's what I'm trying to do here. I'm deciphering all the results in a particular format and putting it in a list. That list here is nothing but the details, and this list I'm passing it here in details, and all the tracking results are now stored in this tracks. Now in next step, let's try to decipher the contents inside this track. So let me write a for loop for this. So here we are getting the track ID from the track here, and we are getting the bounding box detail here. Now let's try to put the bounding box, and not bounding box, let's try to put the ID number of each tracked object on in middle of that bounding box. So this is how I'm going to do it on a particular frame using that ID. I am assigning the track ID here. This is here, and using that bounding box, this is nothing but the middle of our bounding box. So if this is a bounding box, this is your center point, and this is x and y, and x and y is nothing but bb box 0 and bb box 1. So actually for simplicity, let me do like that. This coordinate will go here, this is the midpoint of our bounding box, and the y coordinate will go here. All right, now let's run our code and see what is the output. Amazing. You see here, on each and every detected vehicle on this highway, we have assigned a unique ID. Benefit of assigning unique ID here is that we are able to successfully distinguish between two vehicles here. For example, vehicle number this and this are completely different because its ID is 4 and its ID is 12. Pretty amazing, isn't it? Now, till now, we have successfully detected moving vehicles on a road, and on top of that vehicle, we have also applied our tracking algorithm. In next step, let's draw a line on this highway, and let's try to count the number of vehicles moving in and out through that line. So this is my draw line function. So this will draw 3 lines on the highway, 1, 2 and 3, and these are the coordinate system. So you can do little bit of hit and trial if your image size is different. So with my image size, this is the coordinate which I'm getting, 950 to 258, which is this point, and point 2 is 950 to 454, which is this point. So it's like for different types of line where you want to draw, you can choose your own coordinates, but for the sake of convenience, I have taken almost middle of this image. And using cv.line here, I am drawing the line on top of the image, and rest code is pretty much simple. Now let's try to call this code from our loop here. So where we are capturing frame, we will try to call it here. Okay, so this is our while loop. Here we are grabbing each and every frame one by one, and ideally this line should be present in each and every frame. So before doing any sort of prediction here, we will try to draw our line here. So let's capture the frame, and instead of image we are passing frame. Perfect. Now let's just run and see whether we have successfully drawn the lines on top of our highway or not. Pretty amazing, isn't it? So this is our lane 1, this is our lane 2, and this is our lane 3. We have successfully drawn a line on our this beautiful highway. Okay, so next step from here is to count the number of moving vehicles on this highway. In next step, before jumping directly into our programming, let's understand a bit of theory of how we are going to implement vehicle counting mechanism. Okay, so this is our lane 1 here, this is our lane 2, and this is lane 3. Pretty much self-explanatory. Now to implement the logic of vehicle counting here, let's first try to implement our logic in lane 1, and then we will try to replicate the same logic in lane 2 and lane 3. Let me zoom in the lane 1 for you. Perfect. Lane 1, this is the XY coordinate 950 and 258, and this is the XY coordinate of 950 and 454 of this line. So ideally any vehicle on this side of the line we are counting it, any vehicle on this side of the line we are not counting it. In a real time scenario, the moment this vehicle ID 12 crosses the line, we should be counting it. So let's suppose I have a point here inside a bounding box. Let me create the bounding box, and this point value is x and y. So if y value is between 258 to 554, that means this bounding box or this vehicle is in lane 1. By similar logic, let me go to lane 2 for you. So suppose I have a point here, and this is the bounding box. Suppose this y value is between, let me give a y value here, it's 500 and it is 700 here. So if y value here is between 500 to 700, that means our vehicle is in lane 2. By similar logic, if my y value here is 900 and here it is 1200, if I have a bounding box here, and let me make it x and y, and if y is between 900 to 1200, that means our vehicle or our object is in lane 3. Perfect. With this logic we can identify in which current lane our vehicle is moving. Now to implement the logic of object counting, let's see at x value here. First let me delete it, let me make my screen a bit clear. Okay, perfect. Now let's suppose I have a bounding box here. This is the midpoint of my bounding box, and I have this x and y coordinates. And if my x value is greater than 950 here, you see this value here, we have already defined our x value as 950 because we have drawn our line with this value. So throughout the line, if you will see, the x remains constant. If I draw a line from here to here, x will remain constant, only y will change. From here to here y will be different, from here to here y will be different, and from here to here y will be different. And I have already explained you, if my y value is between this range, that means we are in lane 2. If my y value is between this range, that means we are in lane 1. And if my y value is between this, we are in lane 3. Perfect. Now we will check x value. If x is greater than 950, no, yeah, it's 950 here. So if x is greater than 950, that means vehicle has crossed the line. So in that case we will be counting. So in that case our count will be count equal to count plus 1. Perfect. Now let's move to our programming and let's implement this logic. Alright, now let's try to replicate the same logic in our code. Let me first declare all the necessary variables which I am going to need. So I will be needing lane 1, lane 2 count, lane 3 count, and I will be also needing a list to catch all the necessary IDs which I've already counted. Let me go back to my tracking code here. Now let's write the logic to count the number of vehicles in lane 1. So here's my code. I have already extracted x and y, so I'll be using x and y, and let's also create a variable id. Inside id, let's put, it's just a replication of the same variable id equal to track id. I'm doing it to make my code more simple and more beautiful. So if, here's my condition, if x is greater than, so if x is inside lane 1, not lane 1, if x crosses the green line, so this is the green line, And if that X is not counted, not X, the ID, and Y is between 258 to 554. Amazing. This is pretty simple assignment here. So we are checking whether we have crossed the line here or not, and we are checking whether we have counted this ID or not. And here we are checking vertically whether this is in lane 1 or lane 2. So this is my coordinate for lane 1. And moment these all conditions are satisfied, let me first catch my ID. So I will append that inside my list. There are you. Append ID. There you go. And the moment I have appended my ID, let me count the variable. So lane 1 is equal to lane 1 plus 1. This is simple maths. So anything inside this variable will be plus 1, and that's it. Now let's try to put the text in there. Okay, so we are using cv.putText to put our counter here, and this is the coordinate at 100 cross 100 we are trying to. In fact, let me copy this put text and put it in earlier place also, so that it's visible to all the time. Otherwise it will be visible only when we are counting it. So I have put my lane 1 counting here. I have also created a rectangle, a filled rectangle, so that the visibility is very much fine. And I have also created lane 2 variable here just for the reference, so that in future that's how I'm going to count all the vehicles on particular lanes. And let's go back to my code and let's reiterate what we have done here. So here I have extracted x, y, and id of each detected object. Be mindful, whatever we are talking here is on each detected object, and on each detected object we are trying to check whether it satisfies all our condition to be in lane 1. This is the most important condition here. If x crosses the 950 round, that means 950 is the x coordinate for our the green line which we have drawn on the highway, and we are checking whether its id is not in our catch id. The moment it's in catch id, that means we have already counted that id. That's pretty much simple. And using this we are counting in which lane we are in right now. So this is the coordinate for our lane 1, and here we are just counting it. Here we are just putting the string count. Now let's just run this code and see whether we are able to successfully count the numbers moving vehicles on that particular highway or not. Oh, I did a mistake here. It should be 454, 454, and one more mistake here is there. It should be lane 2, not lane 1. Otherwise, it will show me the lane 1 count at both places. Now all is perfect. Let's just try to run the code. Perfect. So we are counting only the vehicles in lane 1, and it is working pretty perfectly. So it's counting 1, 2, 3, 4, 5, 6, and 7. So we have 7. That's pretty much amazing. Perfect. The results are quite amazing. Now what we will do, it's time to copy our code. So we will use the same logic for lane 2, and let me copy it here for you. Perfect. Instead of if, it should be else if. So if it is not in lane 1, we will check for lane 2, and we will check the coordinates here. So x should be greater than 950. That will remain as it is. I don't know why I deleted that. We will only change the y coordinates here. So what should be the y coordinates? It should be 530 and 694, and it should be lane 2 here, not lane 1. And the coordinates here should be, where is my lane 2? 500 cross 100. So it should be 500 cross 100. That's it. Super easy, isn't it? Same logic, whatever we have done here, we are replicating here. And there is one more error here. If you have pointed it out, it should be lane 2. Otherwise, it will be counting lane 1 always. That would be, dubious mistake. Okay, so let's run. So we have lane 1 and lane 2 counting 0. Let's see what happens. Okay, so we are counting both lane 1 and lane 2. Inside lane 2, we have 3 vehicles counting done till now, and inside lane 7, we have 7 vehicles counting. That's in lane 2. Let's see, check 1, 2, and 3. Perfect, good. It's not bad. And this vehicle has crossed lane 2. So let's see what will happen. Okay, so the count is increasing. 1, 2, 3, and 4. Quite good. Amazing. I hope you are with me till now. Now let's try to count the number of vehicles in lane 3. Let me copy the code here. You see, the life is easy if you have implemented the counting for only one lane, and what we are doing, we are just copy pasting the same code. What should be the here? It should be less than 950. So ideally in this case we are crossing from opposite side, so that's why I have put it less than here. And id logic will remain same, and y coordinates will change here from, what is my coordinates, it should be 30 to 940 here. Perfect. So here we are checking in which lane you are. So you are in lane 3. Here we are checking whether the id is counted or not, and here we are checking whether you have crossed our line or not. Perfect. And rest all logic remains same, but again same error. I should make it 3. It should be 3 here. It should be 3 here as well. That's it. All changes are done. One more change need to be done. I need to give the coordinate system here. Let's add one more 0 here, and let me copy this and put it here as well. Where is my earlier code? There you go. So let me put my lane 3 logic here as well. So lane 3, and we are putting it at 1000 cross 100. That's it. That's it. Super easy. Let me just change the color of my lane 3. So it's, let me just make it which color you like. Let me make it 200, just a random color. Let's see what happens. Same color I will have to add it here, not 2000. That will give you an error. It should be 200. That's it. Super easy. Oh, I have done in lane 2. It should be not in lane 2. What a lame mistake I was going to do. It should be here, 2000. See that this, see, this is what happens if you write a lot of code. My mind is going dumb. Let me just run it. Okay, so here is my code and here's my output. Okay, so on lane 1 we have 5 vehicles, lane 2 we have 3 vehicles, lane 3 we have 4 vehicles. Pretty amazing, isn't it? So in lane 3, let me count 1, 2, 3. Okay, it's only 3 vehicles. I don't know where is the 4th vehicle. It might have crossed the line. Pretty amazing result. I mean, I'm pretty much impressed with this code. This can be applied on any sort of tracking vehicle movement. And in future, we can also use the same code base to generate an heat map on top of it. Alright folks, so this is it for the current tutorial. Please leave a comment and a like if you have learned something interesting today. Also, if you are interested in generating a heat map from a YOLO model, check out my other videos. See you in next video guys.